Welcome to TIA's Connectivity Jam, where we have the pleasure of speaking with leaders in our industry on key topics that drive businesses. Joining us on this segment of TIA Now is Trevor Smith, Vice President of Strategy and Business Development at CommScope. Welcome, Trevor.
Thank you.
What is the capacity for growth of the network regarding the coming convergence of wired and wireless networks?
You know, it's really interesting how fast the network is growing. Really been growing, the upload speed's been growing like 45%, somewhere between 18 and 22 months every time it doubles. And it's really driven today by consumer demand for something that, what we call a smartphone. If you think about all of our smartphones, they're really the most personal computer that we've ever owned. And we're entering an era where it's becoming far more important. It's gone from something that's been nice to have to something that we need to have. You can actually liken it to the automobile industry, as autos went from something that enabled personal mobility, allowed people to get from point A to point B as quickly as they wanted in the time that they wanted to be. Now we have a smartphone that allows them to get the data they want, when they want it, how they want it. In fact, as we interviewed people around the world from San Francisco to Sao Paulo to London to Hong Kong, what we found is that more people, both in the millennial generation as well as in the baby boomer generation, they all would rather give up indoor plumbing than give up their smartphone. So this is telling us that that bandwidth growth is not going to decline anytime soon. I think one thing that people misunderstand about this is it's not all downstream either. The upstream is actually growing faster than the downstream. We're generating more content at the edge. We're generating more content as users, which is meaning that we need to make the network more capable in the upload than it has been, and that's growing faster than the download of the network as well. This isn't just going to stop with social media, with crowdsourcing, because as we think about the Internet of Things, what we're going to find is that we're going to see such rich content, such rich information coming from video that we'll be uploading that video into the cloud and using tools like AI to help understand the context of what's happening, and then react with much smaller bits of information that are sent back to users and allow them to take action based on that.
How are you preparing for 5G at the physical layer?
You know, preparing for 5G is really an interesting question. We don't know exactly what 5G will be yet. We know it wants to be a network of networks. We know it wants to enable things like enhanced mobile broadband, massive machine-to-machine computing, and ultra high reliable, low latency networks. But we don't really know what it will be yet. It's still evolving. And so as you're thinking about preparing for it, you can do things like lay extra fiber in the ground and make fiber available in lots of locations. You can do things like when you put up antennas, make extra ports available for coming 5G bands. But without knowing exactly what it's going to do, you need to think about things like virtualization, optimization, and densification as things that can help you as 5G comes.
Please talk further about the needs for the following in this transition to 5G, the needs of densification, the needs of optimization, and the needs of virtualization in the network.
I'd be happy to. So if we think about densification, we think about today, much of our wireless communications are done via macro sites, and these macro sites are big tall towers that are put very far apart and somewhat visually obtrusive in the areas that we see them. As we think about densification, we're going to have somewhere on the order of 10 to 20 times more cell sites that are allowing people to communicate with the network. Actually, not just people, but also machines, as we talked about earlier. This densification, though, is going to require something different. These antennas won't be as high in the air. They will be, maybe on rooftops. They may be on street poles. They may be disguised as trees. We'll have to think about ways to make the visual pollution less. We'll have to think about ways to make them still able to have site access so that we can put them where they're effective from an RF coverage standpoint, ways that we can get power to them so that we can power the antennas and the radios that are broadcasting this RF spectrum. And we'll have to think about the backhaul, which is likely mostly going to be fiber, bringing it back into the rest of the network. That's one way you can do densification. Another way we can do densification is via adding sectors to existing macro sites. So today, lots of macro sites are made up of, say 3 sets of radios, many more than 3 often, but 3 sectors with radios pointing, at roughly 3 different directions. You can do things like, double the amount of sectors. You can go to 6 sectors per macro station. This would also be another type of densification where you can get, more signal through that existing space. If we think about optimization, there's a lot of things that you can be doing in planning now to work on optimization as well. You can think about things like carrier aggregation, taking multiple frequencies and adding them together to get more bandwidth to users. You can do this with both licensed and unlicensed spectrum. There's new standards coming out that allow you to aggregate non-licensed spectrum with licensed spectrum to get even greater throughput and greater data to users. You can also refarm some of your older spectrum, right? Things like 2G and 3G spectrum. While you can't eliminate all of it because of some of the legacy services, you can start to move some of those and plan for moving some of those legacy spectrum to newer spectrum that you might use for 5G in the future if the standards end up allowing that to happen in the spectrum that you're interested in. Finally, there's things like virtualization that you can work towards as well. And lots happening right now in virtualization. Actually, it's a key theme of the jam here this week. If you think about virtualization, one of the big topics in virtualization for 5G is about how do you split the RAN and how do you virtualize the RAN. And it's likely going to be that there's going to be several ways that this happens. I think there's as many as 7 or 8 proposals of what the RAN split for 5G could be. I don't know that all of them will make it. It seems right now that maybe just something like two of those different splits may make the final standard. But thinking about how that's going to happen, thinking about where do you place your assets is something you can do now. So placing compute resources in your central offices, placing compute resources in cabinets that you may have in the outside plant, making them ready so that as you move to this virtualized RAN, you can do the type of compute that's required to deliver the type of services that you want to deliver via something called network slicing that's going to be likely a part of 5G as well. So while we can't tell you exactly what to do for 5G, there's a lot of things you can do to really plan for it and to start to prepare. You can do things like add fiber deep in the network. That gives you that ability to go to a small cell environment. Sometimes that'll be outdoors, sometimes it'll be indoors. That's generally classified as densification. You can do things like plan on spectrum and think about how you're going to arrive at the right spectrum decisions and how you're going to aggregate that spectrum, and that's often called optimization. Then you can also do things like planning about where do you want to do your compute, where do you want to store which types of data in your network, and this is really part of that virtualization story that's going to happen as well.
Thank you for being with us today, Trevor.
Great, thank you.